Hi, I'm Yusuf. In this video, we will look at machine a 5-axis positioning part. Our part has angled surfaces and a pocket and two holes. So we need to machine it with a 5-axis machine. Okay, let's start. First, we must define the workpiece, but we must close these holes and these pockets before. We must fill it with an sided surface. We click turn to boundary, tangent curves, click OK, click OK, and click OK. We switch to manufacturing and we define the workpiece. First delete them. We choose the solid part and switch to face and select those surfaces again. We click OK. As not usual, we define a blank here. We define the blank and we drag it under the mill joint. So now we have a blank and we have workpiece under the blank. Why do we do this? Because we will use different workpieces when drilling and machining this pocket. We will use different workpiece, so we will have one blank and different workpieces. Okay, let's create a cavity mill. We have actually simultaneous 5-axis, but we generally use mill contour or mill planer in roughing because it is more stable. Okay. Depth first. We open the corners. Height, transfer rapid. And click generate. For a faster verifying, I change it to 3 because we will wait in simulation, in machine simulation. Okay, but we will change it to mill semi-finish for a stock. Okay, our roughing is finished. Let's look at this. I click OK. Now we will machine these phases. I use floor and wall for this operation. I just click the surface, click OK, change the cut pattern. I can change the maximum distance and click generate. I click OK. I copy that, paste it, and choose another surface, another floor, and click generate. As you can see, we do not define any tool axis. I just choose the floor. It's all. Okay, it's a formed surface, so I must machine it with a ball mill and with contour array operation. On parts and click generate. Okay. The outer surface is finished. I click CTRL plus W and hide the sheet bodies. And I want to machine this pocket. I create operation, cavity mill, flat 8, mill semi-finish. We generally don't choose the cut area, but in 5-axis operations, cavity mill operations, I generally choose. I define the tool axis. Okay, and I change the transfer rapids. And click generate. No. Okay. I must switch workpiece from blank because in the previous workpiece this pocket is closed. I must choose this solid body again, and I must click generate. The tool pad starts from the 0, so I must change this cut level and click generate again. Okay, you must change these engage parameters. You must change ramp angle and you must change the height for a smoother engage. Okay, I finished the roughing and I must make the finish. I choose it with a radius mill. Tangent faces. I made the same thing with cavity mill. Okay. Optimized. Stagger ramp on part, cut between levels. Not use depth of cuts. Use the person tool flats and click generate. I made the same mistake. I must switch to blank and choose the workpiece and click generate. Okay. I made the finish, and the last I will drill these holes. Create operation, not workpiece, blank, drilling tool, not that level, it's hole making, drill. Okay, I just select the holes, that's all. You can change the depth for these holes. I click generates and have the toolpaths, but there's a problem with clearance. I change the clearance, transfer rapid, plane, click OK and generate. Let's look this. Repeat. It makes a simultaneous air move. Some old machines can't make this simultaneous move, and some posts do not support this air move. So you can choose one hole and drill another hole in another operation. Okay. It's all for these parts. Let's make a verify. The tool changes its angle. Tool axis changes. Okay, it's all for verification. I click OK, and I want to make a simulation. Simulate machine, but first we must show the machine. Okay, let's simulate it. It's because I must make a folder, program folder, and simulate machine. You can see the axis here. It's A axis, it's C axis, X, Y, Z, you know that. They are the posts, and let's start this. Show tool trace, show tool path. Okay, let's look how it changed the tool axis. It finished the cavity mill and switch to face milling. There is Z0 and axis changes A26 and C90. Machines the floor, then Z goes to reference, and it makes the A and C changes. And it lifts again. In every in the end of all operations, there must be that reference code, because if there is not that code, you will actually we usually have crashes. So don't forget to add the post guy that code. It makes the finish of the pockets. Let me show that slower. Okay. We'll start from the end of finish of the pocket. Okay. The finish ends here. Tool lifts. Actually, spindles like that. All axis goes to reference, tool change, and it makes the first drilling operation. Lifts up. Makes the second operation. Actually, in this setup, drilling isn't made like this. In Verify, you can see that there is a simultaneous ear remove, but this machine doesn't accept this. You can arrange it like that. But in serial parts, in mass production, you will lose time. Okay, It's all for this video. With this model, we started our 5-axis lessons. Thank you for watching. If you have questions, please ask on comments. And if you like the video, please press like button, and if you haven't subscribed yet, please subscribe.